Oh, yes.
Anyway, we are going to talk about the differences between sympathetic nervous system and parasympathetic nervous system. If I can write here, what is that difference? First and foremost, you need to learn how the autonomic nervous system is behaving. You've seen it has a cell body somewhere. Let me call it my cell body like this, like that, like that, like that. Yeah. So this is the cell body. It is going, and it is let me use one line to be systematic. It is going, and it is making a synapse at the ganglion. Yeah. Then another neuron is leaving the ganglion and continuing to supply the vesicles, the visceral organs. And it said that the difference comes from the motor portion of the autonomic nervous system. The apparent portion is always similar, majorly, except the locations, but that is it. So, as we are comparing, we are going to base on the cell body, we are going to base on ganglion, we are going to base on effector. We are going to talk about neurotransmitter at effector level. We're going to talk about neurotransmitter at ganglion level. We're going to talk about the position of the cell body. Yes, you recall they're talking about the thoracolumbar outflow, the craniosacral outflow. They come in here. The difference, that's what I'm here to explain today. You just follow, you enjoy the science. Okay? Yeah. Okay, if we are to start, let me put this slide here such that you can be following. We said you must talk about this neuron, the ganglion, and the effector. The neurotransmitter at effector level, the ganglion, the neurotransmitter at this level, cell body of the preganglionic neuron. This is cell body of the postganglionic neuron. So it has two neurons along the efferent pathway, and that is the autonomic nervous system. So the sympathetic, the first difference is all about the cell body. Where is the cell body located? Yes, we have the cell body of the sympathetic nervous system located between T1, yes, to L2, but where exactly the spinal cord? In the spinal cord, it is found at a level which you can call, they are located in the intermedial lateral horn. We talked about this in the previous video. And thoracolumbar outflow. It forms the thoracolumbar outflow. Then the parasympathetic nervous system, it is located in the cranial nerves cell bodies which are found in the nuclei of cranial nerve 3, which is oculomotor, the facial nerve, that is 7, cranial nerve 9, glossopharyngeal, and cranial nerve 10, which is the vagus nerve. You get it? That is where we find the cell body. So at this point, what we are talking about is the cell body. Where is it located? It is located in the nuclei of those cranial nerves. That is one. It is also located at the sacral level, S2 to S4, between S2, S3, S4. There you find parasympathetic nervous system. This forms the cranial outflow, this forms the sacral outflow, and these two you can summarize them as craniosacral outflow, but this one is thoracolumbar outflow. You get it? Yeah. So here we've been comparing location of the cell bodies. Cell bodies of what? Of the preganglionic neuron. or preganglionic neuron, PGN. Yeah, preganglionic neuron is what we've been comparing. The cell body, where is it located? So that is the first difference. The second, you look at this. You can talk about the ganglia. Yes, the components of the sympathetic are consolidated. I mean, they are united, and the ganglia forming a sympathetic chain. Components are consolidated. Yes, the ganglia united to form a sympathetic chain. Yes, but on the other side, each ganglion exists is isolated. Yes, that is true. Even the components of the nervous system is isolated. This is, we shall see it later, that you can cause a mass sympathetic discharge, but you cannot cause a parasympathetic discharge which is massive, which cannot fight or which can do a spread. So here we shall be having components which are isolated at thoracolumbar level and sacrocranial level, craniosacral level. That is the second difference. The third difference we can talk about. Allow me to talk about the preganglionic fibers. How do they appear? Preganglionic fibers. Preganglionic fibers, they are myelinated, that is true for both. Yeah. And they are short. They are short in sympathetic. Why are they short? Because this thing at the thoracolumbar level, it is too close to where the ganglia are located. You get it? Because the ganglia are paravertebral. In fact, the ganglion of sympathetic, if I can describe a little more about it, we shall have the paravertebral ganglia, which are just on the sides of vertebra, and those will be having cervical, thoracal, lumbar, sacral. There are many. Those ganglia forming the sympathetic chain. There are two sympathetic chains which are terminate downwards or cardially or distally. They terminate into a single ganglion called it ganglion impulse. Yes, that is ganglion impulse. But now another thing is that the thoracic, the last cervical or the inferior cervical ganglion and the thoracic ganglion, they synapse, they unite to form a single ganglion called the stellate ganglion. Yeah, we said the inferior cervical and the superior thoracic, or the first is thoracic. They form something called a stellate ganglion by uniting. You keep it like that, keep it simple. We continue. So we say the preganglion fibers are short. Whereas this side, and they are short and myelinated. This side, the preganglionic nerve fibers are long. Yes, they are long. Where do they terminate? For preganglionic fibers, they will be terminating in paravertebral ganglia, which I've said is those forming the sympathetic chain. The prevertebral ganglia, we have the celiac ganglion, inferior mesenteric ganglion, and the superior mesenteric ganglion. And also the which you can call internal ganglion. These are found in the organs they innervate. For example, you can have the heart, you can have the urinary bladder, you can have, it's called the HABP, something like that. The heart, urinary bladder, the bronchi, yes, and it will be studying for something else. But there are four organs which are basically having internal ganglia, which have just a connection to CNS by the preganglionic nerve fiber. So those are three types of ganglion in which the preganglionic fibers are stopping or synapsing. As for parasympathetic nervous system, you'll see that the preganglion fibers are long, and they will go to ganglia. Yes, which ganglia? The ganglia here are inside, in, or near to what? To the organ it innervates. Yeah? Yes, it is close to or inside the organ innervated by the parasympathetic nervous system. That's why they are too long. It has to travel from cranium and go downwards to supply, for example, the esophagus. Supply things like the heart. Supply things like the heart. And the fourth difference we shall talk about here is the neurotransmitter. You can see the sympathetic nervous system. The neurotransmitter is the neurotransmitter here for the sympathetic nervous system is mostly adrenergic. Yes, mostly adrenergic. Why am I saying adrenergic? And that is going too fast. Because we say this is the thing we follow. We shall talk about having the neurotransmitter at two levels. You have that released at the ganglion. Yes, you have neurotransmitter at ganglion. Yes, and that released at effector organ. So that of ganglion is always acetylcholine. Acetylcholine. That at the effector level will be mostly adrenergic. Mostly adrenergic. Yeah. Whereas for parasympathetic nervous system, the neurotransmitter will be acetylcholine for both ganglion level and the effector level. So those are four differences. We can talk about the fifth difference. We follow that. Yeah, we just follow that. And the fifth difference is going to be about the effect. The effective for sympathetic nervous system. You can see we said they diverge, they show divergence. Like a single preganglionic neuron can diverge and synapse in many ganglia, so it can cause a massive diverse effect. So the effect is widespread for sympathetic. For the parasympathetic nervous system, the effect will be discrete. It will be to just a single organ, because we shall see that a single preganglionic neuron will make just a single or two synapses. So the effect is too local to either a system or to an organ. You get it? Okay, now we are going to talk about the functional differences. These were majorly anatomical differences, and I've said the last difference has been about the effect. Which effect? We said it is local for this, it is widespread for this. There is a massive sympathetic discharge, whereas for this, the effect is too local to an organ or a system. So we're going to talk about the functional differences, and we shall call it a day. We just continue. Okay. The functional differences. Okay. When we talk about functional differences, there are many. According to the organ it innervates. Yeah. First of all, we'll say that the sympathetic effect is widespread. There is a sympathetic massive discharge, because we say they make several synapses in single, like a single preganglionic neuron making several synapses in several postganglionic or in several ganglia up or below, so causing a sympathetic massive discharge. Which importance of this massive discharge? The importance of this discharge is just simple. One, it will help in the fright. Yes, it will also help in the fight, for flight and fight response. Whereas the parasympathetic is discrete, to help in these things. Discrete or localized, what you can say localized to an organ or system. So, what is the role of this local effect is to cause three things: majorly digestion, the cut rest. They are normal things to do daily. Elimination and three things: digestion, elimination, and what? Yeah. And pumping of the heart. There are many. So when you compare when you talk about digestion, will be increasing GIT motility, yeah, will be increasing GIT secretions, they are increasing motility, absorption, there are many concerning digestion. It is normal when you are at rest, yeah. So elimination, that is elimination, defecation reflex, you call it. Another difference, if you can talk about and it is function, is related with the pupil. What happens? The sympathetic, because they occur when you need to be seeing everywhere, it means you have to be dilated. The pupil has to be dilated. Yes, this one dilates pupil. We call that muscle pupil dilate. The pupil dilator muscle. Dilator pupillae. Then we also have this side. It will cause constriction. You are at rest. You don't need to be at that alert. This one will also increase alertness. Alertness, parasympathetic increases alertness. Alertness will increase in sympathetic nervous system. You need to be alert so that you fight, and it will also increase energy production. Yeah, you need energy to run. So it is called the catabolic nervous system, because it is causing production of a lot of energy which is produced by breaking down compounds, but not absorption. So this one will be anabolic. It's called anabolic nervous system because it causes digestion to supply energy containing compounds to the body. So those are the major differences we can talk about, but many are there: bradycardia, tachycardia. This one will cause tachycardia. You need to run, you need to supply blood to vital organs. It will cause high increased blood flow to the lungs to pick up the much oxygen. It will increase the respiratory rate, yeah, to supply more oxygen to the tissue such that you can run, and it will cause vasoconstriction of blood vessels in the periphery such that if you get a wound as you're running, you don't lose a lot of blood, cause volume shock. Respiratory volume shock. So there are many. You just subscribe. Thank you. Subscribe. Reason number 1, subscribe. Reason number 2, subscribe. Reason number 3, subscribe. David 7, Sassy Theatre, we love you all.